Okay, so remember that the reason that we're talking about powers of 10 and exponents, the whole goal of this whole unit is that we want to make easy ways to multiply and divide and work with really, really big numbers or really, really small numbers. So something like this, 0.00002, you can work with that number, but it might be easier to work with in scientific notation. So we're going to start talking about how to actually compute with those numbers. And before we start talking about that, we need to figure out the rules of exponents, because there are rules of exponents that make life a lot easier if you memorize them. They're little like shortcut tricks. So what we're going to talk about today is the multiplication rules with exponents. So take a look at this right here. If I wrote this expanded out, what would it look like? What would this look like? 5 times 5 times 5. And what would this look like? Times 5 times 5, right? We've got 3 and we've got 2. So I can do all that, but how would I write this if I wanted to condense it back? This would be the same as what? 5 to the power of 5. So 5 to the 5th power. All right, does anybody notice anything that you could do that in a shortcut way without having to expand it out? Emily? Yeah, just add your exponents together. So if you've got 5 to the power of 3 and 5 to the power of 2, that means you have 3 5s and 2 5s. So really you have 5 5s. All right? So when you're multiplying exponents together, the shortcut way to do it is to do what with your exponents? Okay, does that work if you had something like this? No, why not? They don't have the same constant. They don't have the same base. So you can multiply exponents to do that. You can add together the exponents as long as they have an equal base. All right, so as long as the base is the same, you can add together your exponents as a shortcut. So right here it says 6 to the 7 times 6 to the 4th actually equals 6 to the 11th because 7 plus 4 is 11. So when you're multiplying with exponents, you can add them as a shortcut. Brendan?
What if you're dividing?
We're going to talk about that later.
Okay, and you can't add them if you're subtracting?
No, if you're subtracting or adding, that's very different. Good question, though, because if you look at this, if you had 5 to the 3rd minus 5 to the 2nd, this would be 5 times 5 times 5 is 125. And then 5 to the 2nd is 25, and that equals 100. And this isn't a power of 5. So you can't, there's not rules for adding and subtracting. The good news is I'm not going to ask you to do that. So we're really only going to multiply and divide. All right? Do you have a guess on what you might do with division?
I guess you're going to subtract.
Probably subtract, yeah. Okay. So then try these. What would A be? 2 to the 11. Good, 2 to the 11th. What about this one? You just add the ones that are the same, right? So just like when you have combining like terms, you can only put together the ones with the same variables. Here you can only put together the ones with the same bases. So what can I put together with 4 to the 2nd? 4 to the 5th, which would give me 4 to the 7th. And then I have 3 to the negative 2 and 3 to the 6th. So what would that be? 3 to the 4th. Ash, where'd you get that from? Good, because you're putting together a negative and a positive. So if you do negative 2 plus 6, that gives you 4. Perfect. All right, can you combine these? No, they have different bases. You can't combine them, so you're done there. All right, now I'm not going to ask you guys to multiply these out. This is where I want you to get. So don't worry about figuring out what 4 to the 7th is and 3 to the 4th is. At this point, the whole point of doing this is trying to condense it down so we can work with simpler numbers. All right, what about C? What would C be if I simplified it? A to the 6th, B to the 5. Good. All right, what about D?
Y to the negative 1.
Y to the negative 1. How come?
Because I did 2 plus negative 2.
Okay.
I did the 1 is positive. So
What 1? I don't see a 1 there. Exactly. Where is this imaginary 1?
Right next to the y.
Right next to this y. If there is no exponent, we imagine it's a positive 1. So you do 2 plus 1, which gives you 3, and then 3 minus 4, which is negative 1. So it's y to the negative 1. Now I can't leave it like this. Why not? It's got a negative exponent. You can't leave it like that. So what should this look like? 1 over y to the positive 1. Do you need that one down there? No. So you could just put 1 over y. All right? That's the same thing. So the only simplifying you have to do is if you have a negative exponent, you got to get rid of it. All right? Because we don't like negative exponents. They're uncomfortable. They don't really make sense. So we're trying to get rid of the negative exponents. Okay, go do these 8. Okay, so again, what are the rules with multiplying exponents? Add the exponents, keep the base the same, keep the base positive, keep it the same, good. And then for ones like number 1, number 2, number 14, if they don't have an exponent, what's there? An imaginary 1. So make sure you add that, because this is 3 to the 1 and 3 to the 3rd, so this would actually give you 3 to the 4th. Good. All right, and then for number 12, when you have 4 to the negative 3, 4 to the negative 2, that gives you 4 to the negative 5, but we can't leave it like that, so what does that look like? 1 over positive 5. Good. 1 over 4 to the positive 5. All right, what would this look like? What would this look like if I just wrote it out? This would look like 3 times... Okay. How many times do I need to write this? 5 more times? Well, five times total. So I'm going to do this times I'm getting bored. Almost done. All right, is that 5? So how many 3s is that total? 20. So it's actually 3 to the what power? 20th power. Now, I don't know about you guys, but I don't want to write that out every time. That's very annoying, right? So does anybody see what you could do to get that? That would be a shortcut. Angel? Multiply the exponents. So when you have a base and an exponent raised to another exponent, you multiply them. All right, so again, the difference is if we had 3 to the 4th times 3 to the 5th, this would give us 3 to the 9th. But when you have a number raised to a power raised to another power, then you multiply them. Okay, because that means you've got 3 to the 4th 5 times. So that's 23s. All right, so that is an exponent raised to another power. So a power raised to another power equals that base raised to the product of the exponents. So again, product. And the shortcut here is that you just multiply them, which is way faster than writing it out and counting them all up. Okay? So a power raised to a power, you multiply them. How are you going to recognize that? When there's parentheses? Okay. How does this look different than this one? How else does this look different? Besides that this one has parentheses. There's not a multiplication symbol. Okay. Sometimes parentheses mean multiplication, though. So I could technically write this like 3 to the 4th, 3 to the 5th, and that would still be 3 to the 9th. So how do you know when you multiply it and when you add it? Ash?
If the other exponent is outside the parentheses.
Okay, the other exponent is outside the parentheses. How many exponents do you have here?
2.
How many bases?
1.
How many exponents do you have here?
2.
How many bases? 2. All right, so you've only got one base here, and your exponent's raised to another exponent. So like Brendan said, like Ash said, you've got parentheses, but make sure one of your exponents is outside of the parentheses, whereas down here there's still 2 bases with both exponents inside the parentheses. Okay, so what would this one give us? 7 to the 12th. Good. What would this one give us? What would it be? 3 to the 0, which is what? 1. Good. What about this one? What about this one?
First you do this, which gives you
First you do this, which gives you x to the negative 8 times x to the 5th. So then what do you do with these? Add them, and that gives you negative 8 plus 5 is negative 3. And how do I write that? Okay, so the first thing you did was this, which gave you to the negative 8th. Then now you have two bases, so you add them together, which gives you negative 3. Technically, you're subtracting, because when you have one negative and one positive, it's subtraction. But you're adding those together. Negative 8 plus 5 gives you negative 3. We can't leave it like this, because negative exponents are uncomfortable. So we move it down to the bottom and put a 1 on top. Questions on how we got C, where that came from? Okay. All right, what about this? What do you think here? Emily, what do you think? You think you multiply it? Multiply what? 3 and 4. 3 and 4 is in parentheses, so if you multiply those, what would it give you? 12 to the third. Oh, that's a 13. 12 to the third. All right. Can someone do that on a calculator? What is 12 to the third? 1728. All right. Does anybody see another, like, what else could you maybe do? What do you think, Brennan?
I'm thinking you can
Distribute the exponent? What would that look like? If you distributed the exponent, would look like 3 to the third times 4 to the third. Let's see if that works. So what's 3 to the third? No, 3 to the third is 27. And what's 4 to the third? 64. What's 27 times 64? Is it? Are you sure? 7. It is also 1728? So do both of those ways work? Yes? Okay, so you can either multiply these times each other and then raise it to the power. And again, you don't necessarily need to do this. I just wanted to see if they were the same. All right? Or you can distribute the exponent to whatever's inside here. The reason that you want to be able to do this is because what if you had this? Can you do A times B? No, you can't do A times B because you don't know what A is and you don't know what B is. So if you simplify this, what would it look like? A to the third times B to the third. Good. Okay, so you need to be able to do it both ways. Obviously, I don't care if you do, if it's just numbers, it doesn't matter to me which way you do it. But if it's variables and it says simplify, to simplify this, you've got to distribute that exponent. All right, so whatever way is easy for you, honestly, this is probably the same amount of time as this, as long as you can do these two in your heads. But if you can't, you have a calculator anyway. All right, so just remember, parentheses mean you do that first. The only issue is when it's variables, you can't really do that first because there's nothing you can do there. All right, so what would this look like then? What would letter A look like? It'd be negative 3 to the second times x to the second. Can you simplify either of those? Yeah? Really? You can do negative 3. What's negative 3 squared? If it's in parentheses, it would be a positive 9. So 9x squared. What would be the difference here? The negative is where? Outside the parentheses. So that means your answer is going to be negative. So it would end up being the same thing except negative 9x squared. All right, so the exponent goes with the 3 and the x. 3 squared is 9, x squared is x squared, and then the negative is on the outside, so you keep it negative. Okay, hey George, go ahead and do these 8.